And here's our last video of an example of conservation of momentum. This is the Mastery B3 problem, and it reads this. A 5-kilogram rock, initially at rest, explodes, sending 2 fragments to the left and 1 to the right as shown below. What is the velocity of the fragment moving to the right? Okay, so first, I'd like to point out that this is it's a little bit different from our other one. So first, note that the rock, our initial scenario is that there's a 5-kilogram rock at rest. So there's only one object in the beginning, okay? There's only one object, and that's at rest. So the other part is that, other thing that's different is that instead of working with just overall 2 objects, we've got 3. We have this object 1, we've got an object 2, and here's an object 3. And now, this scenario, where you start with one object, and it's generally not moving, you start with one object, and you end up with more than one, has a special name, and that name is an explosion. Basically, this is like a reversed version of a perfectly inelastic collision. It's kind of a special case of it. Let me see. So, how do you want to handle this? So note that whenever you have, for every other object that you've got, you need to add in another line on your table. And in the beginning on this one, so there's my other line. And again, everything that we're doing in here is just we're going to add everything up and put it all together. Well, on this one, because of the fact that it was initially at rest and was initially one object, well, the momentum of at rest is 0. Okay, so that's where we're starting for that side. Now, on the after, let's play with this a little bit. So we'll start with object 1, and that has a mass of, that's got a mass of 1.25, and it's being multiplied by -40. And it's negative because it's going to the left, and that's going to give us a momentum of -50 kilogram meters per second. Now our second object, here's our first, here's our second, has a mass of 0.75 kilograms, and it's moving at 100 meters per second to the left, giving us a total after momentum for object 2 of 75 kilogram meters per second. And now we've got object 3, and its mass is not on the board. So in this case, they gave us nothing for the mass, so we're going to have to think our way through it. Now we know in the beginning there was a total mass, and that was equal to 5 kilograms. Afterwards, there were 3. So we've got, afterward there was a mass 1, mass 2, and a mass 3, and that third mass is what we're looking for. So let's just solve this like an algebra problem. So mass 1 is 1.25 kilograms, and our mass 2 is 0.75 kilograms, and we're going to solve for mass 3. So we got 5 kilograms is equal to 2 kilograms, add those two values together, plus the third mass, minus 2. So our third mass, therefore, must be 3 kilograms. Okay, and so that means, so back into here, so we're going to take our mass of 3 kilograms and we're going to multiply it by some unknown variable v. Now when I add these up, I have to use the same sort of logic that we do in algebra. You have to do like terms. So our like terms are, we have two numbers, -50 plus forgot that in there, 75. Those are like terms. And we have to keep separate our unlike terms. That 3v is a totally separate deal. Same as before, our before momentum equals our after. So it resolves like this, -125 plus 3v. And I'm just going to solve for that velocity. And that'll be our final velocity of that third piece. So we're going to add 125 to each side. And that gives us 3 times our velocity is equal to 125 divided by 3. Therefore, our velocity is 41.6 repeating meters per second. And note this is positive, which makes sense because an explosion, everything on one side has to equal everything on the other. Because again, our initial momentum is 0. And that's our last problem. Good luck. We'll spend some more time. We got our test coming up at the end of the week. Let me know if you have any questions. Take care.